there's just so much information and the details about how things fit together that I want to go through a few more examples. So here's the top of a wall and how that wall fits together. You can actually see the lumber used on the top of that wall. Hard to visualize how that all comes together until you see it for the first time. So here's a picture of the layers, not of the actual wall that we're working on, but one very similar. And this is a picture of what it might look like when it's completed. Here's an interesting detail of how two walls are coming together. Right? You got the bus bay on one side where you only need to protect so much. You've got the wall of the building. Well, how's that coming together? When you look at this detail, you can see that every line of flashing and every part of the detail is drawn so that you know exactly what you need to do to build it. When it comes to structural details, you know exactly how much rebar is used in the system, the type of rebar, the type of anchor bolts. All that is highly detailed in the drawings for you. Notice in this picture how the anchor bolts tie the columns to the footings. So we're transferring the load of the building through the columns into the footings. And this shows us how that happens. But how does that column actually connect to the footing? Well, there's a detail on that. And we can see in that detail that there's a metal plate that the column is welded to, and then that metal plate is bolted to the footing through those anchor bolts. What about the way the roof trusses sit on the wide flange beams? How does that work? Well, there's a detail for that. And in that detail, we can see the angle steel, the columns, the trusses, the wide flange beam. It's all right there for us. And then we have these designators to tell us what to do. Now, you're not going to find a legend or a schedule for these designations. These are weld designations. It is an industry standard. Therefore, you'll just have to know what they are or look them up in the industry standard. And here's a table of all the different weld symbols. So we can actually look at the weld symbol on our drawing, match it to the one on the table to get an understanding of what type of weld that should be. And you can see that this weld at the top is different than this weld at the bottom. But do you know why it's different? You'll need to understand that, not because you're going to be out there welding, but you're going to be out there looking at welds, and you need to know that it was welded properly. You need to know that if the weld symbol indicated to go all around, that the weld is actually all around and not just tacked on a couple sides. You should know enough that if the weld symbol indicates that the weld should be on both sides, say both sides of the truss to the wide flange beam, that you'll see a weld in the field on both sides. And then the last thing that we'll cover in this section are the vertically braced frames. Well, what is a vertically braced frame? Basically a steel structure. We have columns, wide flange beams, roof trusses. Well, vertically braced frames are to add bracing to the structure to resist movement. Now you can find these vertically braced frames on sheet S101, the structural drawing. Find column line 1. Follow it down until you get to column lines G and H. You can see in this area that you have a vertically braced frame. And here is an example of what a vertically braced frame looks like.